study development of phonological and orthographic parafoveal processing during reading in Russian. When we read, the most information we receive foveally. Fovea is the central area of an eye, which contains the most light-sensitive receptors. Information that we get foveally, the eye perceives as clearly as possible. Many studies have shown that to the left and to the right of this foveal region, there is the parafoveal region. And the readers can receive some information parafoveally before fixating on the word. So when we read from the left to the right, we can get some information about the word from the right parafoveally, and this parafoveal processing facilitates the foveal processing. So when we fixate on this word when it is in the foveal region. It is known that we can get phonological and orthographic information parafoveally. Studies that investigate parafoveal processing use the GAZE-contingent boundary paradigm. In this paradigm, there is a target word. Here you can see the target word eyes. And the researcher places the invisible boundary, the invisible to participants, before this target word, so that when the reader's eyes are to the left of this boundary, the reader sees another word called preview instead of the target word. So here the reader sees the preview dogs in the parafoveal region when the reader's eyes are to the left of the boundary, which is after the word there. And then when the reader's eyes cross this boundary, the preview is quickly replaced by the target word so that the participant doesn't notice it. And so the researchers can manipulate some characteristics of this preview, for example, phonological and orthographic characteristics, and estimate how it will affect the fixation duration on the target word when it is in the foveal region. As for children, it is known that children who are learning to read initially rely more on phonological information, whereas reliance on orthographic information develops later. And in languages like German, it is known that 8-year-old children rely more on phonological information in the parafoveal region, whereas adults rely more on the orthographic information. In our study, we want to investigate whether there is this shift from the greater reliance on phonological to the greater reliance on orthographic information in Russian. So our hypothesis is that 8-year-old children will rely on phonological but not on orthographic information in the parafoveal region, whereas 11-year-old children and adults will rely more on orthographic but not on phonological information. We have chosen 11-year-old children because it is known that their reading parameters reach the adult level by the age of 11 years old. We use 60 target nouns as the materials. They are 5 letters long. And we have generated 5 preview conditions for each target word. First, an identical condition. So here you can see conditions for the word pie, pirog. Then a pseudo-homophone. Here, this word pirog shares the pronunciation of the target word, but we changed the last letter of it. Then we have control condition for pseudo-homophone, which has other and another last letter. Then transposed letter condition, where we have transposed internal letters of the target word, and the control condition for transposed letter condition, where we substituted these transposed letters. All target nouns are embedded in sentences which are from 7 to 9 words long. All target nouns are preceded by adjectives, and we have placed an invisible boundary after the last letter of an adjective. So here you can see an example of the sentence, "There was a sweet raspberry pie on the kitchen table." And we see that when the reader's eyes are to the left of this boundary, so for example, when they are on the word sladky, the reader sees there is another word instead of the target word. There is a preview pirog in the parafoveal region. And then when the reader's eyes cross this boundary, the pirog changes to pirog. We plan to test 50 participants in each group. However, now we have only 44 young adults, 11 second graders, and 14 fourth graders. Prior to the experiment, we assessed children's hearing, intelligence with Raven's progressive matrices, and reading skills. As for procedure, participants read 60 sentences, which contain all conditions, and they are presented on a monitor. And participants have to answer questions after 20 of them, and there are 2 breaks. We use 2 iLink eye trackers to record participants' eyes, and we have done only descriptive statistics now because we haven't gained all data. We have first fixation duration and gaze duration as our dependent measures. And here you can see the preliminary results for adults. So we can see that pseudo-homophones provoke longer fixations on the target word than transposed letter condition. So that when adults see pseudo-homophone in the parafoveal region, it takes longer for them to process target word when they fixate on it. So we can conclude that adults really rely more on the orthographic information in the parafoveal region. As for second graders, we can see that transposed letter conditions in their parafoveal region provoke longer fixations on the target word. So it is more difficult for second graders to process the target when they see transposed letter condition. And this shows us that children who are second graders rely more on the phonological information in the parafoveal region. And as for fourth graders, we can see that the duration fixations on the target word after when there were pseudo-homophones in the parafoveal region are longer than when there were the transposed letter conditions. So we can conclude that fourth graders, like adults, rely more on the orthographic but not phonological information than phonological information in the parafoveal region. Our study is ongoing, so we are going to have more serious analysis. And now that's all. Thank you for your attention, and I'll be glad to answer questions.
All right, thank you, Vladislava. Questions? Any hands in the participants list? So could you perhaps maybe speculate, given that these are not final data, what happens? Why do these patterns change with age, and quite dramatically, actually?
Yes, So children go from the great reliance on okay, so children who are second graders just study to read, and their reading is more sublexical, and it is more phonematic. And as the reading experience is bigger, they begin to read more like adults and go to the lexical strategy when the orthographic information is more important. So it depends on the reading skills, which depend on age also.
Right, yeah, okay, thank you. I think there was a question from Елизавета Galperina. You want to ask it, or you want to read from?
I can ask it also.
Yeah, go ahead.
So,
go ahead.
So how do you assess reading skills in your students in second graders?
We used Konev's test. So second graders and fourth graders needed to read the text.
Oh, thank you. I know this test. Thank you. Okay.
Maybe the rest of us want to.
Oh, sorry.
Okay, so children read the text for a minute, and then we count the number of words that they read correctly, and then they also need to answer questions, so that we assess the correctness of their reading and the number and how they understand the text.
Right. Okay. Thank you very much. Any more questions? Anybody else?
Yes, hi. Do you know if there's a relationship between how they understand the text and the type of reading patterns?
There is a relationship between the correctness of the reading and their reading skills at all. We think that children who performed normally in this test can be included in our experiment.
Right. Anyone else? Right. If there are no more questions, let's thank Vladislava and wish you good luck continuing and finishing this study.